So here's an example of taking a graph and writing an equation of it through transformations. So as I look at this graph, I notice this shape, it's a parabola. So that means that my parent graph must be x squared. So I know my equation is going to have this in it. And then I want to find a couple other things. I want to find, the parent graph would have originally been at 0, 0, the vertex of it. And notice this is shifted over 1, that's that one part, and then shifted up 2. And by over, I mean to the right, and then up 2. So, and that just shows up in the vertex, that's the coordinates of the vertex. So essentially I've shifted right 1, that's my h value, so I'm going to be subtracting 1 inside. I'm affecting x before the function takes hold. And then I'm adding 2 to it to shift it up, adding 2 outside of the function. And then the next thing that I need to do is figure out my a value, figure out how it grew. Typically parabolas go over 1, up 1, and then over 1, up 3. And notice that this parabola is going over 1, up 3 right off the bat. So if it usually goes over 1, up 3, the growth has been tripled. So that's my multiplier. That's this part out here. And there's an equation for it. That is an equation for that graph. And one thing that I want to point out is kind of the interplay between h and k and how they have the same effect no matter what function you're doing. So for example, if I wanted to graph the function same a value, different function, I'm going to do absolute value, same h value, same k value. Everything's the same. That vertex is still going to be at 1, 2. It's still going to have a growth of 3, so over 1, up 3. But instead of being a parabola, it would be an absolute value, which is just that straight line v coming up through those points. So same transformations on it, same changes, just different parent shape.